So yeah, the database lab, we are part of the computer science and engineering department, and which is part of the Jacobs School of Engineering. But we also have members from the Halajolo Data Science Institute now. So I'm in with both, and I'm affiliated with both too. This is our overview of the current database faculty: Lynn, me, Yanis, Babak, and Victor. Yanis is currently on leave. He's at Amazon AWS Redshift. The current research topics, I just did a tally after Babak joined. Now it seems like we are one of the largest database groups in the area of data analytics, Alan. I think we are one of the strongest groups in the world, even compared to, probably comparable to Berkeley and MIT in the data analytics space, spanning systems for ML, data science, polystore systems, graph analytic systems, causal inference, responsible data science, and a bunch of other topics. So that's pretty exciting. We also have work on interactive data exploration, new query interfaces, and other sort of data management topics, and more theoretical work on verification of data-driven workflows. And the database group has a website that was refurbished and launched last year. So you can go check out the group website there as well, dbucsd.github.io. Some salient statistics and facts. So, sorry, trying to record this, but it's not showing my face. Okay, there we go. Great. Current students, we have 9 PhD students, I believe. That's the latest tally I saw from our website. We have 1 master's student and 3 undergrads, at least. Sorry if I missed anyone. And this is one of the longest running database research groups in the world. And so we have a huge number of top tier database conference publications. We prefer publishing a lot in the top tier, highly visible venues. Sigmod, VLDB on the database system side, PODS and ICDT on the database theory side. And there was also a lot of journal papers you could see in our publications history. Victor and his colleagues wrote the Foundations of Databases textbook, which is the standard textbook in database theory. If you don't know that, I myself, as a graduate student, studied that book for our qualifying exam at the University of Wisconsin. And I also wrote a textbook along with a couple of other ML systems area colleagues, data management and ML systems. That was an invited book. It's more tailored towards graduate students interested in research in the space. Victor has had extensive collaboration with INRIA in France, and I believe he's still in France right now, and that's why he's not able to join live. But he is meeting with some of the visitors one-on-one, I believe. Some major research awards, we like to just showcase these, I guess. It's, you know, like your hall of trophies. So Yanis, Alan, Victor, me, Babak, all of us. Across the board, we have awards from federal agencies, from nonprofits, from conferences, and so on. Okay, so let's move on. Research impact. A lot of the database group's research is not just ending up in papers and you just leave it there. Some of our research also transitions to practice, and we collaborate with industry. We like to kind of transition the research to practice to achieve impact as well. Here are some examples. Yanis founded a startup, so this is one way to do this, and it got acquired. Yanis also worked on some research in the last few years that got integrated into various AWS products, so SQL++, and also products outside of AWS, like Couchbase. Alan, Victor, and team proposed some process verification ideas that I believe was integrated with IBM's products. Some of my own research have been integrated with products by several database companies, web companies, and cloud providers. There are several patents some of these faculty have. I myself don't have a patent yet. There's 1 pending, or maybe 2 pending, I guess. There is alumni who have done really well in industry. Some examples here: Yushu started GraphSQL, and I believe they have 150 mil plus funding raised. Michalis, another alumnus, he's now the director of BigQuery, the cloud native RDBMS, the database engine that is the flagship product for Google Cloud. And there are several others, I guess, in our alumni that I haven't listed here. We have alumni spanning industry, academia, and startups as well. Okay, so now we're going to go through a brief overview of every individual faculty member's current research. Okay, so that's first up is me, because I'm the one speaking. My research focuses on the overall life cycle of the machine learning-based data analytics kind of situation. We talk to data scientists, ML engineers, and practice. I've spoken with over 36 of them at various enterprise web and other companies and domain sciences and digital humanities and so on, and abstracted this into three main parts: the source, build, and the deploy processes. Source takes the raw data to ML-ready data, build converts the ML-ready data to prediction functions, and deploy integrates the prediction functions with the application. All of this happens on data systems and machine learning systems infrastructure. In my research, I'm largely agnostic to what that infrastructure is. I'm more interested in the fundamentals of this whole lifecycle and the process, and try to improve that process. And I approach this from the standpoint of building new abstractions, new systems, and new techniques that make this whole lifecycle easier, more scalable, faster, and cheaper. And a lot of these techniques come from the database systems world, things like query optimization, schema management, and so on. And my whole vision is that the ML application space, ML system space, is circa, it's like reminiscent of databases circa 1980s. So we need a lot of work to be done in the ML system space, inspired by database systems, to make this easier, scalable, faster, and cheaper. And that's my group webpage, awcsd.github.io. Feel free to check that out. For more details about my research, I'll just give a brief summary of the two main ongoing top-level projects. Project Triptych, we are looking at the sourcing and the building stage, where we find that model selection is too painful and resource intensive, configuring features, getting the data in shape, configuring the model architecture or the algorithm, and tuning the knobs of the algorithm, hyperparameters. This leads to a lot of pain for the users. It leads to higher resource costs. And so in our project, we approach this from a database lens. We elevate this process to higher level APIs, some of which are already popular in practice, and think about it more holistically. With that holistic view, we can now apply database-inspired system optimization techniques that allow us to reduce runtime, reduce resource costs, improve energy efficiency, and all of these good things that we like in systems. It also allows us to do automation of grunt work that is happening today manually. And this automation can be machine learning based in itself. So we're using ML for ML via database ideas. Some of this work has had some early impact. I've been fortunate. And apart from stuff from my thesis work that got adopted by likes of Oracle and MATLAB Pivotal, some of our recent research has also been adopted by MATLAB and Pivotal, which is now part of VMware, and by Google. And so some of these grad students you're meeting, Supon, Braj, and Yuha, some of their work has actually been shipped by some of these companies, and it's being used internally by some of these companies. We're collaborating with them too. And some of the systems we built out of this project are being used right now by public health domain scientists at UC San Diego on terabyte scale data for deep learning. And we are also starting collaborations with material scientists and potentially also physicists, computational physicists, for using some of our systems from this project. So a lot of the work that we do, we like to interact with practitioners to get inspiration for workloads, for bottlenecks, and understanding how we can come up with new systems and techniques to mitigate those bottlenecks. The other project, Genesis, is more out there, I guess. Here, the notion of using deep learning to analyze unstructured data, what we found was it is too painful in practice because there's so much that is preventing domain scientists and enterprises from adopting deep learning. And we wanted to tackle this from both the scalability and the usability standpoint. And this vision is what I call database perception systems. We want to open up this black box of deep learning models to allow us to exploit new techniques, to build new interfaces to interact with data, say like speech recognition based interfaces and other interfaces, and also explain the predictions of these models so that we can understand them in terms of the data a little bit better. And we approach that again from a database standpoint. The hope is, now this is a very recent style of work, that it'll enable us to put deep nets in the hands of more users that may not have ML expertise. They do not need to be PhDs in machine learning to be able to use deep learning for unstructured data. That's the hope. These are my current awesome advisees. I hope I didn't miss anyone. I have a large group now. I think I'm at the capacity. So I have 5 PhD students, actually 6 PhD students, 1 co-advised, and 3 undergraduate researchers in my lab right now. And like we saw during the introduction, some of them are returning students. So Shubin and Sita graduated with another degree and then came back. Raj and Yuhao are master students who switched to the PhD program here after they continued working with me. Supun and Tara joined afresh. Advitya, Kabir, and Xiaoqing are all undergraduate researchers. Of course, Kabir is also a visitor, so he has this problem of figuring out what questions to ask and how to answer them himself. Moving on, we have Alan. Alan, would you like to walk through this yourself, or shall I walk through it?
I'm happy to do it. It's not my slide, it's my work, so I'm not sure which is the better solution.
It's your slide deck, but you can walk through it. I can do what you say.
Okay. Can you maximize it?
Yeah.
Okay, so I work on various projects, but the one we're highlighting here has to do with a notion that is called hybrid stores, also known as polystores in the literature, which starts from the observation that oftentimes you need to perform analytics that require certain operations that are better supported by one kind of system than another. And instead of just taking the data you have and centralizing it onto the system and then noticing that, whoops, I'm trying to do something here that the system is not so good at, the alternative is to just put the parts of the data that have to undergo a certain operation in that system that is best suited for it. And instead of attempting to centralize all the data, we query across these systems. And not only do we place data in the system that's best suited for it. For example, I have to run some machine learning operation, then I'm not going to necessarily do it in a graph database. But in addition, I may want to cover the situation where the data is born that way. It is initially natively generated as a graph or as text or as JSON or as relational tables. And I un, un, until I'm forced to, I don't want to move it around. Now, this kind of system has been looked at in the literature for quite a while. The difference between what they used to do and what we do is that um, we give a way to optimize queries that go across such systems by defining views that themselves go across systems and even across models. You can write a view that joins this unstructured text that you have in this particular text index with these tables from a relational database and with these JSON documents from a JSON database. And then when a query comes in, you can rewrite the query to take advantage of this pre-computed view. Okay. And the whole idea here is that it means that you have to solve um, technical problems of reasoning about the semantics of your queries, reasoning about the semantics of what you have already pre-computed across models. And doing this across model is novel. And we have come up with a very powerful paradigm for doing this, which is to reduce everything to a single data model and query language, which is a relational model, a relational query language, very much like what you have heard about when you studied SQL. However, you add to that very powerful integrity constraints about the data, which have to reflect how your modeling of JSON, of graph data, of text, and so on is reflected in relations. And then together with these integrity constraints, we rewrite user queries. And this has led to a very nice line of work at this point, very nice, interesting preliminary results. And I have a student, Diana Abutaibi, who couldn't make it here, but she's available if you'd like to talk to her. She's leading this project and she has at this point extended polystores to even throw in matrices and start thinking about queries that do, typical relational algebra style operations, but then also mix in some matrix manipulations. And um, she she has very spectacular and non-obvious rewritings between these kind of queries. So let me stop here with that and invite you to email us anytime. We have many other projects that we'd love to tell you about.
Okay, thank you, Alan. Next, we have Victor. And Alan, you've collaborated with Victor on this. Do you want to take this one too?
Sure. This is a very different project, which has to do with automatic verification of data-driven workflows. So by which I mean a workflow, a business process that is governed by a bunch of rules and that runs on top of a database. Um, Even think of the workflow that you're going through at Amazon, where first you type in the name of an author and that the website gives you back the list of books, and then you click on the book, and the website gives you back the resulting details, and then finally you make a decision to buy. There will be payments, there will be shipments, there might be you complaining that you didn't get the shipment, and so on. All of these stages in the workflow are actually governed by business rules. And before you deploy a complex workflow such as this one, and there are others that are way more complex, you want to verify statically at design time that it will satisfy, it will guarantee certain properties regardless of what stupid thing the user types in, regardless of what the contents of the database may be. So what we do is we express this kind of properties in a formalism known as temporal logic. It allows you to talk about time. It allows you to say, if the user made the proper payment now, then eventually in time, the product will be shipped or the user's money will be refunded, for example. Or there is no way the user could navigate their way through the menus and get this product shipped without having paid or without having paid the right amount for this product. All of this could be a bug in the system that we want to rule out before deployment. And we do so by means of static verification, where we formalize the specification of the system in terms of its business rules as a large, um, if you will, state machine, not a finite state machine, but a state machine. And then we ask about possible paths through the various states of the system that might lead to an unwanted state. And such a possible path is what we call a counterexample, and we show counterexamples here. And there are very interesting applications to this. We have had even industrial impact here. IBM has a business process specification formalism called the guard stage milestone um, artifact system, and we can verify that, and ideas from there have made it into a standard for business process specification. We also have a PhD student who graduated. His name is Yuliang Li, who is now working in research at Megagon Labs, and whose thesis was in this area and is pushing it further. So this project is alive and well, and the student who is currently carrying the torch in this general area is Marisia Pian, whom you see there on the very right, and who is possibly among our audience here. So she's the one to ask about this particular kind of project. Rana is the one in the middle, and Ainul on the left is my other PhD student who works on parallelizing SQL queries by translating them to queries over graph execution platforms. So if you've heard of Giraffe, of GraphLab, of Pregel in general, these allow you to program in parallel over large graphs in a scalable way. And we are interested in taking SQL there. And we have some interesting results that show that you can actually beat the big commercial vendors such as Oracle and Microsoft at their own game, at their own benchmarks, the ones that they measure themselves by, such as the LDBC, the TPCH and TPC-DS benchmarks. And she can tell you more about that. So let me stop at that for now.
Okay, great. Thank you, Alan. That was awesome. Okay. Next up, we have Babak. And Babak is here. Babak, you can take it, I guess. Here we go. We'll put this in full screen mode. Yes, go for it, Babak.
Okay, sounds good. Hi again, everyone. So my research is motivated to address some key challenges in data science, namely how we can ensure the conclusion that we make out of the data science pipeline are fair, valid, reliable. How can we build transparent algorithms so that the decisions becomes indisputable and the customers will trust our system? And how we can remove bias from data and protect data from bias during its life cycle. In my group, in my research group, we look into the entire data science pipeline to address issues related to transparency, explainability, bias, and discrimination at different stages. And if you're wondering why on earth a database person would be interested in topics such as algorithmic fairness and transparency, then I would say that in most situations, the problem is with the input, with raw data that is the input to the data science pipeline. So in that sense, bias is inherently a data quality problem, and dealing with bias, I would argue, is basically a data management problem. So our work in the context of algorithmic fairness essentially address issues related to bias and discrimination by bringing together techniques from graphical models and databases to kind of clean data for the purpose of machine learning. Even if the input to the data science pipeline is totally bias-free data, each and every step during the data science pipeline, for instance, during data transformation, data cleaning, and data integration, they can actually introduce bias out of the blue or exacerbate the existing bias in data. So in this context, my ongoing work tries to bring, again, together techniques from data management, database provenance, query optimization to develop techniques that enables us to efficiently explain root causes of bias and to correct for them. And then in general, I believe generating different forms of explanations in data analysis is crucial for trustworthy data analysis and for understanding data and avoiding false conclusions. So during my PhD and my postdoc, I've published several papers in the context of explanations in decision-making systems and generating explanation for analytical queries. But right now I have an ongoing project that look into generating explanation for black box machine learning algorithms. And then finally, my research, in addition to data management, my research is grounded in causal inference, because I believe causal inference can serve as foundation for reasoning about bias and fairness and avoiding false conclusions and generate explanations. Next, I'm going to briefly discuss two of my ongoing projects. So the first one, LUIS, which is a system for generating explanations for decision-making algorithm. The goal of this project, so let me start here. So today, machine learning algorithms are increasingly used for in sensitive domains such as criminal justice system and in healthcare to make consequential decisions for human decisions that has to do with humans' life. Therefore, there has been a call for algorithmic fairness and explainability and transparency, which basically aims to generate human understandable explanations for decisions made by this algorithm to ensure that they behave as they intended to. Lots of solution has been proposed for explainability and transparency during the past few years. It's a very busy space. However, most of these solutions, they basically look into statistical correlation between inputs of an algorithm and its output. Therefore, it has been shown that explanation generated by these existing solutions could be inconsistent, misleading, and wrong. In this project, our goal is to develop a novel causality-based framework for generating explanations that unifies many of the existing solutions and addresses their limitations. Our framework basically uses what I call probabilistic contrastive counterfactuals that essentially quantifies to what extent changing input features of an individual would change the result of algorithm from positive to negative and vice versa. And by doing so, our system, can you show the next slide? By doing so, our system is basically able to quantify causal relationship between input features and algorithm decisions and generate explanations that are provably correct. We showed that the explanation generated by this system goes beyond state-of-the-art explanation methods in explainable AI, such as LIME and CHOP. And then our system can further generate actionable insights and recourse for users in order to be able to change for them to be able to change the result of the algorithm in the future. Next slide. So different explanations generated by our system, LUIS, or other tools in explainable AI are crucial for the end user to understand the internal logics of a machine learning algorithm by revealing how the input features are related to the output of the systems. But if you now think about the problem of transparency from the perspective of a practitioner or a data scientist, the expectations from explanations are somehow different. Practitioners need tools to be able to explain the decisions made by algorithm in terms of the training data and the decision that they make during the pre-processing data that actually lead to training data. For instance, they need explanations of the form that Babak's loan application got rejected by this algorithm because of the existence of particular data points in training data that the algorithm was trained on. Or algorithms, or in the context of algorithm that decide about loan, maybe the practitioner needs to generate explanations of the form that this particular algorithm exhibit discriminatory behavior for all African American females because they had a large portion of missing attributes in the training data, which was imputed by this imputation method, which introduced bias along the way. So, or in general explanations in terms of any other decision that we make during the machine learning pipeline when we pre-process data. So I believe generating these diagnostic explanations are crucial for debugging systems. And the goal of this project, again, is to bring together techniques from data provenance, query optimization, and machine learning to efficiently generate such diagnostic explanations. I have another slide, I think.
There we go.
So yeah, right now, I just, like I told you, I just joined UCSD. Right now I have only one postdoc. She's working with me on both of the project that I discussed. I also mentor a master's student and an undergrad student. Thank you. I'll be happy to pick questions after Arvin's talk.
Thank you, Babak, about San Diego's data tech ecosystem. So sorry, I think the Zoom is not cooperating. There we go. We have, apart from the database lab and CSE, we have the San Diego Supercomputer Center on the left over there. They are a very historic supercomputing facility in the country. They have a whole bevy of researchers and engineers and system admins and folks. We have supercomputers that give us access to enormous amounts of compute power and storage power. And some of these database researchers there, Amarnath is something that Shuan mentioned, but Amarnath is one. There's Ilkay, there's Chaitan, there's Mai. These are folks in the data management system space as well, who also do research. For example, Wildfire and Words, these are like tools for data science and wildfire management, applying data science to that have come out of that. And Wildfire in particular got a lot of press last year. And there were these huge wildfires in up and down California. It was used in many of these situations, so they do a lot of impactful work. CLDS does a lot of data systems research at large scale for high performance computing. And of course, we have HDSI already mentioned. HDSI is a very eclectic environment with database, machine learning, and statistics, causal inference now with Babak, theoretical computer science, mathematics, and various domain sciences represented there. Political science, oceanography, bioinformatics, biomedical informatics, all of that stuff. So it's a very eclectic environment. There is CalIT2 and the Qualcomm Institute here. They have some researchers there who do data-related stuff. They do healthcare. They do precision medicine. A lot of work there. We have the Center for Network Systems, and both Alan and I are also members of the CNS. They do a lot of large-scale systems, research, cloud computing, hardware, storage, communication infrastructure and stuff. And so we interface with them and go to their events and give talks there as well. The Scripps Research Institute on the bio side, and then there's a whole tech industry that is booming right now. Apart from the Bay Area, I've heard that San Diego is now very hot for both information technology and biotechnology. And so apart from Qualcomm and Teradata, who are headquartered here, very large companies, we also have ID Analytics and more recently AWS. Yanis, whom I mentioned was on leave, is the one who pulled AWS to San Diego. They have an office here. The Redshift team, there's a bunch of researchers and developers there. And then there's Illumina, which is a storied name in the biotech space. Then there's a consortium called Tech San Diego, which pulls together a lot of these companies and universities. There's multiple universities in the town, and researchers and practitioners. I've been to one of their events to kind of listen to some talks. They have periodic meetups as well. And more concretely, in the database lab itself, we have our weekly database seminar just to give you a feel of what life will be like as a database lab student. We have talks by students, faculty, industry visitors. It's a 1-credit course, so once every week. You can volunteer to give talks and get feedback. Most of the database faculty attend all the seminars as much as possible. And even if we can't attend, it's recorded and it's usually made available in these remote teaching times. The HDSI has its own seminar as well for faculty from various fields, including many domain sciences. So if you're interested in data science, you don't want to, you want to make sure that you attend these HDSI seminars. Right now it's for faculty giving talks. Eventually they will launch student seminar series as well. And then there's other related group seminars. AI group has its weekly seminar. The SysNet group has a seminar that you might also be interested in joining and attending. Last thing, we also have these events. We ran the SoCal DB event that I kind of put together with other faculty and industry and support from STSC and HDSI. It was a lot of fun. Go check out this website. This was the first time SoCal DB Day was held. It's like a regional database research and industry workshop, a day-long workshop where students gave poster presentations and got to meet with 6 companies: Amazon, Google, Microsoft, Couchbase, Teradata, and one more, which I forget, which is unfortunate. So there were several of these companies that showed up and gave talks. Go check out the website. We will hopefully hold this again after the pandemic ends. The last one, I launched this Tumblr, just wanted to plug this in. You're welcome to contribute any memes you create about anything related to data systems, for machine learning systems, for data science systems, for data management. Here's an example of that. You know, we talk about deep learning a lot, so I was just memeing about that. So we like to have fun with our research, and we like to do impactful research, but we also like to have fun with research. Okay, so that's up with the presentation. I think what we can do now is take questions from the visitors. If you have any questions.